Hey, it's Mateo Man here, and today we're going to be covering something fun, which is programming your Meshtastic device or your future one. Now, I just want you to step back and imagine a world where you can communicate off-grid without relying on a traditional infrastructure, and that is the power we get from Meshtastic. But how do you unlock it, right? In this video, we're not just going to show you what Meshtastic can do, but I'm going to show you exactly how to program it, transforming you from a curious bystander to a master of decentralized communication. Now, we broke this up into a couple sections. The first thing we're going to cover is just talking generally about this device so that you get some familiarity in what we're about to program. The second thing is going to be that first steps of flashing the firmware and then a little bit of the basic steps of setup, right? Then we'll do a deep dive on customizing your particular mesh along with getting you to connect with the local mesh around you. So that'll be our deep dive, followed by a little bit of real world application and troubleshooting just to see exactly how this guy is working with the local meshes that are nearby. And hopefully we get you from, introductory to proficient, maybe even a pioneer on what we're doing with mesh devices. So let's jump into the first section. What is this right here? This is an Espressif 32 based Meshtastic device with a battery and NMI 3D printed enclosure. Now, why is this useful? Decentralized comm. It's just a cell phone tower and the cell phone all in one device, able to send a lot of text data between a mesh of devices where it can bounce off multiple nodes and come back to you. So it's very efficient at that, right? This is your off-grid or dense communication superpower. Okay. Let's go ahead and start with the flasher and what we're going to be doing here. First of all, there is a web flasher. It's pretty simple to use and allows us to just jump right in and program the device. Now you can also get the app, which you'll need your Android or iOS or web app in order to be able to use the device, and then finally selecting a firmware to use. But this is pretty simple. Let's just go to the web flasher. I just clicked it there and I'm plugged in over USB-C. I'm on my laptop and all right, there's our device, the Heltic Wireless Tracker 1v1. Now, inside this, if you click the device, you can go ahead and select exactly what your device is. The racks are pretty common out there. If you were to grab one of these guys, you have that option. You also have the LilyGos. And for me, I know it's the Heltic, so I'm going to select that one. And then firmware is the second thing we're going to be selecting. And out of here, we're just going for the default beta firmware, which if I wanted to, remember, you could select a custom firmware if you wanted something from the bleeding edge or super stable back in the day. So you can upload your own if you downloaded it and maybe even modified it. Finally, we're going to select flash. Now, there's some warnings and bugs and maintenance and things that are talking about your particular device, so you'll want to read over there. I already have. But here's what's key for this one. I have an Espressif 32 based device, which means there's a particular way that I have to program it. Let's see this camera here where you can see I've got two buttons. This button will reset. This one will put it into programming mode. Now I'm going to end up clicking and holding programming and then clicking the reset once. That will restart the whole device and put it into a mode where it can be programmed. And you're going to see that right now. So I've selected 11.5200 for the baud rate. That's the communication speed that it's going to try to talk to the device. And then finally, there's the full erase and install option, or there's the update. Now, if I do this, it'll totally wipe out my configuration on it, which is what you want to do if this is your first time configuring. But for me, I'm just going to do an update because I'm going to pull it to the newest. So again, I am selecting the program button. I clicked update here. Notice it says COM4, but when I click reset, COM3 appears, and that is a JTAG serial debugger. And when I click connect, kabam, it's now updating over the USB-C. So after it's done updating, we should get a positive response. Cross our fingers. And there it is. It wrote everything 100%, no warnings. That means it was successful at updating. So let's go ahead and look at the device. And ta-da, Meshtastic. All right, it is upside down there, but yeah, this is our Meshtastic device. Now let's go to part 2, which is the deep dive in customizing your mesh and getting this thing configured and showing a real-world application. So let's jump back over to the main screen. First of all, we are plugged in over USB, and now we're back to the downloads page. So meshtastic.org/downloads. On this site, we're now going to go over to the apps, and if you had your iPhone or your Android, you can download the app for this, but we're going to use the web client because, well, it's nice and simple from here. We're already plugged in. I click Serial, and there's my device on Serial. Here we are. The device is booted up, and it's named Rough Device MM19. Now, first thing you might want to do when you get your device connected is change the name. So I've got Rough Device MM19, good with that. And the next thing is, let's cover the details of the navigation panel here for Meshtastic on the web site. So you got messaging, and on messages we have 2 channels that are shown along with all the nearby nodes that you could select and send messages to. The next thing is the map. If we click map, we get this nice map of all the nodes that we can see that are near us, and we'll be diving further into this under the real world application. And then next is the configuration. Under configuration, notice that 3 modules appeared. You have radio, modular, and then the channel configuration. If we click channel, I want you to have this on your first channel. Call it primary, right, for your role. Leave the channel name just open if you want, and then put AQ equal under 8-bit. What this will do is give you the default primary channel that everyone has that we all communicate on to make it so your map populates and you see what devices are near you. If you don't want this, and also you set how accurate it is to be how close to you this device would be, and I'm going to say that I want it within a mile of me and save it. So now the device will restart with that configuration. But then you can also go to modular configs and the radio configs to set up just about every other detail. Now, all I want you to worry about now is this channelizing, right? So you go channel config, click channel 2 in this case, because I don't want to show you mine. And you can give a key here. You can generate a fresh key. So if we say I want a 256-bit generate and then regen, there you go. You've got a fresh AES 256-bit encryption key, and then you can assign a channel name. And I'm going to call this custom name. Now, that's a brand new channel, and I'm going to click save. That just got sent to the device. It's configured it as appropriately stated here, right? All right, and here we are. We have the primary, my custom channel, and then the custom name channel. All right, real world example. We just sent a message on the custom name channel, and we sent it from our device named Rough Device, and that just went out into the ether. What that did is it's now bouncing off the mesh devices, looking for another mesh node that knows what custom name is along with the encryption key. Little hint, there's not one. We just made it. So it's bouncing off of all the nodes looking for anything that might know it. But in truth, there's no other device that's aware of this and communicating the same language as the Rough Device MM19 is doing. So let's go ahead and communicate on a different channel for the real world example. Let's go to primary, and we're going to type in test. So that one went out, and sure enough, we get a little waiting for delivery. If I hover over that, that'll eventually say delivered to some device. Something in the network is familiar with that name and address, and it'll respond back, oh, received. All right, time for the real world applications. Now, 2 things that I want to cover for the real world applications that are important to you. First of all, it's going to be regarding what nodes are near you and how far can you actually communicate to maybe one of the nodes that you own or a nearby node to you. So let's go ahead and take a look at exactly that. Here is our nice map of the area. This is all the nodes that popped up near me. Now notice this is a 5 kilometer scale here. So across this whole screen is probably, I can line it up in the corner there, looks like almost 60 kilometers. And if you take the kilometer math there, that's like 40 miles from this node to there. That actually ranged 40 miles to get there. But how recently have we seen it? And we can go to filter and we can sort by the past 2 days. And then on top of that, we'll say if it's within 3 hops, those are high likelihoods that those nodes will receive your transmissions. And one of them is this device here, the HAL-PV. So HRP2, which we have seen in the past 27 minutes, and it looks like it's reporting well from 3 hops away. So let's do a real-world example of going from where we are at, which is approximately 12 miles from that location, probably closer to 15. This isn't 100% accurate to where I'm at. And let's try and target to HRP2. So we're going to go into the list of nodes, and from here we'll do last heard, and we know we heard HRPV2 20-something minutes ago. There it is, HRPV2. Now, with this guy, let's go ahead and do a trace route to it. Trace route means it is sending a message off to it, and it just said trace route sent. It sent a message to it, and it's waiting for the reply to come back. So if we go look at the map, we should see a full round trip that's occurring, right? This little guy does not have a big antenna on it. Honestly, this antenna, just knowing how dB and this frequency works, probably just goes a couple miles. And they also know there's a mountain range between me and that device. So that means it's going something in the range of nearly like 15 miles over a mountain range for both the to and then the from. Notice I said something about it probably needs to be about 3 hops to be a successful to from. And that's just because some devices are at capacity as they're passing information to and from. So this trace route got sent out, and hopefully it pinged off several devices, got to our target device, who is then pinging back to us. And there you have it. If it gets to the device and the device comes back to us, we will see what devices that were hit along the way in order to go to and from the device back to us. Now, this is useful to then say, yep, check that out. So it went from rough device, this device, to GR211, Terry, and then it got there. Then from Terry back to this 211 to an unknown device, GR, and then back to us. So we had quite a few hops in order to get to and from. Well, I hope that was helpful. We did a full coverage of Meshtastic from the top level of how it's viewing, a meshed network in order to communicate. We programmed the device successfully using this nice little USB-C port and the web client flasher. We did our deep dive to customize and configure our own channels. Finally, by doing a real-world application to show us go more than 10 miles out to a device and send and receive a message through the mesh. So I hope that helps. Again, my name is Mateo Man. Thank you so much for dropping by the channel. Feel free to like, comment, and subscribe. It really helps out the channel as we grow. So again, thank you so much for dropping by. Later.